Fundamental concepts of software objects. Objects are the fundamental component of object-oriented programming. Although we have not yet stated it, all values, in Python are represented as objects. This includes, for example, lists, as well as numeric values. What is an object? The notion of software objects derives from objects in the real world. All objects have certain attributes and behavior. The attributes of a car, for example, include its color, number of miles driven, current location, and so on. Its behaviors include driving the car, changing the number of miles driven attribute, and painting the car, changing its color attribute. What is an object? An object contains a set of attributes, stored in a set of instance variables, and a set of functions called methods that provide its behavior. For example, when sorting a list in procedural programming, there are two distinct entities, a sort function and a list to pass it, as depicted in figure. In object-oriented programming, the sort routine would be part of the object containing the list, depicted in the figure. Here, nameslist is an object instance of the Python built-in list type. All list objects contain the same set of methods. Thus, nameslist is sorted by simply calling that object's sort method. The period is referred to as the dot operator, used to select a member of a given object, in this case, the sort method. Note that no arguments are passed to sort. That is because methods operate on the data of the object that they are part of. Thus, the sort method does not need to be told which list to sort. Object references. In this section we look at how objects are represented, which all values in Python are, and the effect it has on the operations of assignment and comparison, as well as parameter passing. References in Python. In Python, objects are represented as a reference to an object in memory, as shown in figure.
A reference is a value that references, or points to, the location of another entity. Thus, when a new object in Python is created, two entities are stored: the object, and a variable holding a reference to the object. All access to the object is through the reference value. This is depicted in the next figure.
Variables dereferenced values. The value that a reference points to is called the dereferenced value. This is the value that the variable represents, as shown in figure.
We can get the reference value of a variable, that is, the location in which the corresponding object is stored, by use of built-in function id. We see that the dereferenced values of n and k, 10, is stored in the same memory location, whereas the dereferenced value of s, 20, is stored in a different location. Even though n and k are each separately assigned literal value 10, they reference the same instance of 10 in memory, 505,498,136. We would expect there to be separate instances of 10 stored. Python is using a little cleverness here. Since integer values are immutable, it assigned both n and k to the same instance. This saves memory and reduces the number of reference locations that Python must maintain. From the programmer's perspective, however, they can be treated as if they are separate instances. Object references. A reference is a value that references, or points to, the location of another entity. The value that a reference points to is called the dereferenced value. A variable's reference value can be determined with built-in function id. The assignment of references. With our current understanding of references, consider what happens when variable n is assigned to variable k, depicted in figure. When variable n is assigned to k, It is the reference value of k that is assigned, not the dereferenced value 20, as shown in figure. This can be determined by use of the built-in id function, as demonstrated below. We must be aware of the fact, therefore, that when assigning variables referencing mutable values, such as lists, both variables reference the same list instance as well. We will discuss the implication of this next. Finally, we look at what happens when the value of one of the two variables n or k is changed, as depicted in figure. Memory deallocation and garbage collection. Next we consider what happens when, in addition to variable k being reassigned, variable n is reassigned as well. The result is depicted in figure. After n is assigned to 40, the memory location storing integer value 20 is no longer referenced, thus, it can be deallocated. To deallocate a memory location means to change its status from currently in use to available for reuse. In Python, memory deallocation is automatically performed by a process called garbage collection. Garbage collection is a method of automatically determining which locations in memory are no longer in use and deallocating them. The garbage collection process is ongoing during the execution of a Python program.